The first example we're going to consider should look a bit familiar. G of x is defined to be 1 over 1 minus x. Now, using the domain convention, the only x that doesn't make sense to plug into G is 1, because then you're dividing by 0, so the domain is everything except 1. Now, for absolute value of x less than 1, g of x is, well, it's just 1 over 1 minus x, but using the formula for a geometric series, here I have an x instead of an r, but it doesn't matter what letter I use. This is the sum x to the n. 1 plus x squared plus x cubed, etc. Okay, so what have I done? I have represented g as a power series on a certain domain. Represented our function g by a power series but only on a smaller domain. Because remember, this formula, this equality, that 1 over 1 minus x equals this series, only makes sense for absolute value of x less than 1. So I have g that goes from minus 1 to 1 open, this is absolute value of x less than 1, into r, where g of x is 1 over 1 minus x. And that is the same for these x as this series. I.e., this power series representation for G is only valid on minus 1 to 1. So, why would I ever want to do this? I have lost part of the domain of G. I've represented it as a power series, but the formula is only valid on this smaller domain. I originally had G everywhere except 1. So why would I want to do this? That's a very reasonable question. I think it should be the first question you should ask. So why would I want to represent G in this way? Well, first reason. Power series are easy to differentiate and integrate. And we'll see this later, exactly how you differentiate and integrate a power series, but they're easy to differentiate and integrate. So you could have some very complicated G that's hard to integrate, hard to differentiate, and we could represent it as a power series, and these are easy to differentiate or integrate. Second reason, power series are very useful for numerical estimations or approximations. This is what your computer is going to do. It's going to take a function and represent it as a power series. Like in your calculator, sine and cosine are represented by power series. And what your calculator does is it plugs into the first few terms of the power series. We'll talk about that more later. But these are the two main reasons for why you would want to represent a function by a power series.